We're finding solutions to the quadratic equation. Now, I noticed in some previous videos I had a grammar error up here. This should have been Z-E-R-O-S, like I've got it corrected here. I think I had an E in there. Okay, for the plural for zeros, this is the plural. Anyway, all right. Sorry about that. Okay, so what are we doing here? We are going over this quadratic formula, which you should have memorized by now. And I'm just going to write that up here. Negative b plus or minus the square root. I probably need to get the microphone a little closer. B squared minus 4ac. It's all over 2a. And of course, in general form, it's ax squared plus bx plus c is equal to 0. Okay. All right, let's take a look at a problem here. So we have 8t is equal to 5 plus 2t squared. Okay, now you notice we have x is equal to. We don't have any x's in the problem, but hopefully you'll be able to make that adjustment. Let's get this thing written in standard form so it looks a little bit like this here. Okay, so what I'm going to do is I'm going to go ahead and take this 8t over to the right hand side. I think that 5 got a little bit out of control there. It's going to make that a negative 8t plus 2t squared. Okay. In other words, we subtracted 8t from both sides, I should say. Let's go ahead and write this now in that standard form. It's going to be written just a little differently. Okay. 2t squared minus 8t plus 5. Instead of writing, I guess we should just write it like this. All right. However, we need to get rid of that. Okay. So now it's in that standard form you're more familiar with. We know that this is our A, our B, and 5 is our C. So now we can just plug it directly into the formula. Do you remember the formula? Yep, I brought it out of view, so you have to remember it now. So B was negative. We had negative out here, but B is negative 8. So remember to put a parentheses around that. Plus or minus the square root of B squared. So this is going to be negative 8 squared minus 4a, which is 2, times c, which is 5. Okay, and that's going to be all over 2a. That a is 2 there. Okay. So now what we're going to need to do is simplify this thing down. So negative negative makes that a positive. Plus or minus the square root. Okay, so what is all this up underneath here? This is 64 minus, so we have 2 times 4 is 8. 8 times 5 is 40. So we're going to have 64 minus 40. What is 64 minus 40? That's going to be 24. So let's just go ahead and write that in there. And it's all over 4. Okay. Now this here, is there a perfect square hiding in here? Well, let's think about this. We know that 6 times 4 is 24. I do know that. That can be broken down to 2 times 3. So we have 2 times 3 times, this is 2 squared. Okay, so that's one way of looking at this. Right, do we have a perfect square? Well, we've only got one perfect square in here, right here. 2 squared. So we know that if I wrote it like this, 2 squared times 2 times 3. This can be rewritten as the square root of 2 squared times, there's nothing we can do here, so let's just bring that back to 6. But we can square root a square, so that just becomes 2 times the square root of 6. So you see that all reduced down to 2 times the square root of 6. Let's rewrite this. So x is equal to 8 plus or minus 2 times the square root of 6. And it's all over 4. Now, there's a number that goes into both 8, 2, and 4. Do we know what it is so we can reduce this down? Well, we know 2 goes into 8 4 times. 2 goes into 2 1 time, so we'll just write a 1 here, or say we did. And 2 goes into 4 2 times. Okay. Okay. Ugh. So basically what we got going on here is we got the two solutions. X is equal to 4 plus the square root of 6. You could bring that out front and write it like that if you'd like. And then we have x is equal to, just bring that out front. And we have 4 minus the square root of 6. Okay. So here's your two solutions. You can come up here, plug them in, and left-hand side should equal the right-hand side. Okay. If it doesn't, something's wrong. But I checked these, so I know they work. Alright. Well, that pretty much ends this for examples on using the quadratic formula. I think maybe in the next problems we'll have some application problems involving this, where we have to use the quadratic formula to find the solution. I think that'd be a good idea. Okay, I'll see you over there.